Hey guys, my name is xOctoManx and this is part 10 of my Diablo Style RPG tutorial series. In this part we will take care of, the spawning, and maybe we're gonna go into interactions with enemies. Meaning, we're gonna change the system, how we're gonna go and interact with different possibilities of different things like an interaction with a door would be different, of course, like an interaction with one of those signs, or with a chest, or even with loot, and even with enemies itself. So for example, when we are interacting enemies, we want to make sure that we take damage and do damage. That's of course the next step we want to go into. But at the same time, we want to take the same functionality and put this onto everything else we are able to interact with, but we want in the same time, or in the same manner, we want to save some code. So let's get started at first with the spawning itself. When I press play, I'm gonna show you what I mean by that. When we are entering one of our spawn areas from the last video, you can see this, for example, this little Marin in here is not inside the circle, because the formula we were using is a square formula, which means everything around that spawn point in here is going to be spawned actually in a square. We want to change the code so everything is going to be directly inside that particular circle or circle area. Also, as you can see, all of the Marons are looking in the same direction when they're gonna spawn, and I want to change this one as well, so they look into different directions, so it's actually looking, let's say, a bit better maybe, before we gonna go into them closer that they're all also going into and trying to damage us and so on and so forth. So that's what we want to take care of in this video for now, and again we're gonna start over into the interactions as well later on. What I want you to open is the spawn system we just created in the last video. We don't need to take care of update, and even the onDoor Gizmos function is not important for us. I'm gonna zoom in a bit so you can see stuff better. So once again, this is what the square is made of, or basically a point we're gonna create as a vector, and this vector is just an x coordinate and a z coordinate, which is somewhere between the smallest spawn range and the biggest spawn range. But the problem, once again, is that this is going to be a square. If you like to use the square as indicator, you can keep that as it is. But what I want to go is I want to change this one, so we're gonna be able to put everything in the circle area we just created with our handles. So actually not just the visible part, but also any other part is acting and according to that circle. So I comment this out and maybe make another comment over here. So this is for the square, and what we also want to have is we want to have a possibility to spawn in a circle at first. So what do we need for a circle? We need of course a lot of mathematical calculations in here, meaning at first we need some floats which are determining what the next point, or what the random point in the specific circular area is going to be calculated off. So what we start with is a float, and I call this one theta. Theta is a mathematical calculation for polarities, I would say, but I just call it theta because it is, well, the closest to what we are after. Okay, so theta in this case is going to be an angle basically in between the 360 degrees, which is making basically which is creating a circle. There are several possibilities to create and to calculate theta. The first one is going to use whatever a specific number between 0 and 1 is, and then times 2, and then times pi. But also we have the possibility to take the full range of 360 degrees in this case, and we're gonna calculate this times random.value. Random.value returns a number between 0 and 1. Usually that gives us in total a percentage of that particular circle, or an angle and percentage of that particular area basically, or an angle. Okay, so the next one is we want to know how big the radius is where our where our circle is in. And basically we already decided to have a range, and a spawn range in this case, of whatever it is. I believe it was 3 in the inspector. So but what we want to do is we want to have a random radius. This can be in, so we need a minimum and a maximum value. In this case we can use basically the same as we already have done in here, so we get something between 0.1 and 0.0 and 1.0, and whatever our maximum range is the spawn range of that particular circle. Or we can also use RenderedRange. This would not be 100%, but actually 99.99%, meaning RenderedRange is not taking maximum numbers, especially for integers. In this case we're going to use a float, so I believe the most maximum number is not calculated in, but we don't care because actually it doesn't really matter. So the minimum is going to be something around 0. So 0f or just 0. This returns a float later on, of course, and our spawn range. So spawn range, once again, if it is 3, there will be one radius somewhere in between 0 and this maximum spawn range, minus, I believe, 0.00001, which is just the offset the RenderedRange always has in. If it would be a full number in integer and the spawn range would be 99, it will only calculate until 98. So those are the 2 points, or the indicators to calculate a specific point in our circle, or in any circle for the moment. Now we need to make sure that we're gonna set our center. We need the center later on. Basically, center is nothing else than our transformed position of that particular spawn point. So we just make sure we load this in here. We don't need to calculate that, but later on it will just make things easier, since we need to call center several times. Okay, so the next one is we now want to know a specific point as a vector in that circle. So what we need to do is we need to create a new vector 3. In this case, I just call this one point. So this just represents a point somewhere in the circle according to theta and radius, and of course the center at the same time. So how can we calculate this? At first we need to create a new vector 3 in this case, since we need to recalculate that. Open close parentheses, and inside that we need to calculate the x and the z variables. The y will be empty, or in this case it will be 0. So usually we're gonna have 0, 0, 0, which will be just nothing, or just the current position of whatever or wherever we are currently at, basically to the transformed position. But in x we want to use a cosine or a sine wave to calculate where in that particular radius times the current radius times whatever the theta coming off, which is just another random value inside, and we'll put this one into sine wave. So we're gonna take one point in that sine wave's range of whatever we gave it and calculate this. So what we say is radius times, and then we're gonna use masav dot sine. And in open close parentheses, we can put in any float value or variable. In this case, it's going to be the theta variable we just created in here, where we just take any random angle between 0 and 360. Okay, so with that calculated, we can also do the same with the cosine for the z-axis in this case, which will be the back side, the one in the basically in the forward axis in that case. So what we want to do is we want to do the same calculation, but we're going to use, instead of sine wave, we can take the cosine wave. In this case, we take radius times masav dot cosine, so cos, and in open close parentheses we put in the theta once again. Okay, and now we have a radius, or basically a point in a circle, calculated by the beforehand randomly calculated radius and random calculated angle. Okay, so we're gonna have one specific point anywhere in any circle, but we don't have the correct position where this point has to be related to. And since we don't have that, we of course need to once again create a new spawn point, and we need to calculate this, and that is basically as simple as beforehand. So we just say vector3, and we call this one spawn point. Since this is the missing value in here, we just can also go in and copy and paste this one. And what we want to have is we want to add our center plus the correct point we just calculated. So center in this case is transform.position. This point is, I don't know, anywhere in a specific circle, but we want to add those, basically that distance from our current point or from our current center to that particular point. So we need to add those 2 points together. Okay, and what we now have is the instantiation part in here with our new correctly created spawn point. Okay, don't forget to save the script, and let's go back to Unity and test this one out. Meaning we shouldn't be able to get any spawn outside the circle anymore. So when the compiler is done running, we're gonna hit play and walk into our cycle, or circle in this case, and let's see. As you can see, all of them are now inside the circle. We can playtest that the whole time over and over and over again. Actually just one spawned directly inside the circle. It's not too easy to spawn outside, but at the same time, as you can see, let's go into the top view where this guy has been spawned. As you can see, it is still over here, this one. It is still on the outer rim on the circle with its current position, but it's not going further than this one, except it's going to be pushed away from another one, but that usually don't happen, or not so often. Now what we want to add is a random rotation to our enemies. So instead of using quaternion.entity, we want to recalculate the quaternion, or actually the rotation on the y-axis in this case. So it's looking maybe up, maybe down, maybe left, maybe right, or any other angle. So we can do that directly over or under the calculation of the point we were spawning, or we want to spawn. And let's make another note in here. So we calculate basically the look rotation of wherever we are looking or want to look at. At first we create a new float, call this one rot for rotation, going to be equal to any number between 0 and 360. In this case, we're gonna use the same calculation for this one like we did in Theta. So 360 times a random value which will return any angle. Okay, so or any, basically any angle or any number between 0 and 360 once again. So the next one is we want to create a new quaternion. We call this one maybe spawn rotation. Without any typos, and we're gonna set this one equal to, gonna leave a line in here and go up a bit so you can see stuff better. So what we want to do is we want to calculate the new quaternion and make sure that we make that rotation to whenever we spawn one of those guys to the calculated or randomly calculated rotation. In this case we can say quaternion.Euler. And Euler, as you can see, represents a vector, meaning we can now put any float on all 3 angles where we want to make a rotation to. In this case, it would be usually 0, 0, 0 for just quaternion into the vector space without using the W. It's going to be easier to calculate this one. So we just have a value for the X, the Y, and the Z axis basically. In this case, we want only rotate on the y-axis. So instead of a 0 in here, we're gonna put in the rotation we just calculated, in this case, rot. So this now rotation like this. So this now is our new quaternion, or specifically our new angle where we want to rotate our new Marin or new enemy at or to. So we take spawn rotation, and instead of having this one, the quaternion.identity, as a rotation vector or a quaternion, we're gonna put in the spawn rotation we just calculated in here. Don't forget to save, and let's head back to Unity and see what's happening. So I'm gonna go a bit away with my field in here, gonna press play, and when we are entering this circle, we're gonna have spawns somewhere in the red circle, and usually we should have different look rotations where our Marins are looking at. As you can see, the indicator is that little glasses Marin is wearing. So this one is looking to the left, this one is looking to the right, this one is looking, well, I don't know, somewhere else. Well, yeah, another angle. So as you can see, all have now a different look rotation when they get spawned. So one is looking this way, some others looking any other ways. So this means we're gonna have some cool randomization into where they spawn and where they are looking at. And that's cool, and that's what we wanted. Okay, so now we can go into the next step, which will be the interaction in between objects, a bit differently than we have done before, and of course the interaction with enemies. So we can do damage, we can take damage from enemies as well, since basically the enemies are requesting where the player is. We're gonna, I believe we have created the player manager is player manager in this case, so we can use that directly for the enemies, but vice versa, since we're spawning a lot of enemies maybe later on in our game, we want to make sure that we always have the possibility to act or interact with all enemies no matter what. That's what we're gonna do in the next part. Okay, so let's start to talk about inheritance and the interaction possibilities we're gonna have. At first, I'm gonna create a new C# script. I call this one Interactable. So in this Interactable class, basically there wouldn't be anything much, but what we want to have is one access point or one access script where we can derive from and we can talk to. And we want to create one specific function inside that interactable class, and we want to call it whenever we do some interactions. Interactions are, for example, we're going to interact with our enemy in doing damage, and we're going to interact later on with our chests and loot and all the other things we already have, and even those signposts we already created to basically get all things just because, or just with one call basically. So every call into that interactable can be different, and to make this one different, we're gonna create one little function here. I'm gonna zoom in a bit so you can see stuff better once again. So it's going to be public, it's of type void, and we just call this one interact. So meanwhile we are inside of interact. Well, basically we want to just for the moment debug.log. We want to say who are we interacting with, so we actually get a return in return a feedback when we are calling this function correctly. So debug.log you interacted with, and then we make a colon and a space, and behind that we can say plus transform dot name, so we can actually read out the name who is or who we are interacting with. Okay, so this interact method needs to be a specific or a special function, meaning this needs to be of type virtual. Virtual means we are able to override this particular interact functionality with any other different content, no matter where it is. Also, we need to make sure that we inherit mono behavior in this case, but what we want to go into is into enemy behavior, and we're gonna change whoever or wherever we inherit from. So when we go into our enemy behavior, we of course we inherit mono behavior, but we want to do it a bit different. We want to say we want to inherit interactable. Interactable, once again, is this particular script. What we also want to do is we want to create a little helper function inside our enemy behavior, So let me just clamp stuff together. We don't need those. Well, not for the moment. So under anywhere or anywhere in between, I'm gonna create a new specific function, which is called, or actually of type void. It needs to be public as well, otherwise we may not have access later on from outside. So it's public void, and we call this one interact. But the problem is interact already exists. Well, it's not a problem, but the cool thing basically is that interact already exists inside Interactable. So what we do in here, we just say public override void interact. That means the already created function inside Interactable, and because we are inheriting from Interactable, we're gonna be able to override interact wherever it currently is, in this case inside Interactable. So what we can do at first is we can say base dot, and now we can do whatever that function already did. In this case we want to call interact. I believe we need to do it like this. If not, we're gonna change that. So that means everything inside the already created interact function is going to be performed. We can always go and put some code in here. We can also go and put some code in here, but we also can just deactivate the base.interact. What does that mean for our enemy now? Let's go into our Marin. Yeah, maybe we're gonna have to write it as a function like this. So open close parentheses behind that. I believe that's the error we're gonna get here. Yep. So when we are now looking at Marin, Marin still has our enemy behavior script. But since it is inheriting Interactable, we are able to talk to this particular Marin and all the other Marins as well and call interact. So this override function. So when we're calling this, we would automatically call this and would do everything what is inside. In this case, it's going to be the debug.log line. So also at the same time, we can put in all the other stuff we want to do with that particular enemy behavior, or with that enemy in this case. So for example, when we're gonna get hit, when there is an attack performed by the player inside our click to move script, for example, we would be able to call a damage function or a get damage function. And that's cool, since we don't need to differentiate between different objects we are able to interact from. We just need one function, and we call that function on any object we're talking to, so for all enemies as well. So how do we do that? How do we talk to the interact functionality? Well, basically that's super simple. We go to our click to move script, sorry. And what we want to do is, of course, every time we're gonna do an attack to our enemy, so when we have a targeted enemy basically, and if the time for the next attack has happened already, we can do that interaction. We can do it before and or also after the animation.setBall is attacking. And we can also go in and call that function from any point and at any time we want. So in this case, we're gonna land in this particular function, which is the last else if statement, where we are basically doing the attack. In our move and attack function, we can say targeted enemy, and now we can get the component from it, since we know who is targeted, since we already clicked this one. And what we want to get is the interactable game opt, or the interactable component. You now ask yourself, why the hell do we get interactable? Because interactable is not part of that particular game object. Well, actually it still is, because enemy behavior is deriving from interactable, and that's a cool thing. So what we can do, we can also go directly into enemy behavior, but we don't want to. So what we want to call is, inside the interactable, we just want to call the interact function directly on it. So instead of going into the enemy behavior in this case, we go and call it from interact, or basically that connection to that interact method. So what's happening? Let's debug this one later on, so we know what's happening first and what's happening after the one we just did. So for example, when we are able to attack and we do the attack, we go and get the component Interactable from our current selected target, the targeted enemy, and we call the interaction method directly from that interactable object, which is over there. So let's test this one out. So we go to it, we check the console meanwhile next to it once it has been loaded in here, and we go to we double click it, and now you can see you interacted with enemy Marin. So we get in return, every time we're gonna do that attack, we would be able to call that interact functionality. Now let's assume we have something like we want to damage the enemy because we are still in enemy behavior, which is deriving from that interactable. We can now test if we are able to pass over a debug line in here, which maybe says enemy got damage or something like that, got damage. Since at that point we want to call a specific function where we calculate the health and everything else, and what we can do is we can design that particular interact function to however and whatever we want. Okay, so let's get back and see if this is called as well. Meanwhile, we are calling that interact function. So we double click this guy. So what you can see now, the first message in here is the enemy got damage. So why is that happening? Because the enemy got damage method is beforehand the base.interact is going to be active. So after that we get the second message, in this case from the interactable object or C# script, which is telling us who we have interacted with. In this case it has been enemy Marin. So with that, or in that case, we can put now any damage or any healing or everything we want to inside our enemy behavior to basically do damage, calculate damage, do die functionalities and all the other things, because we just have that connection of that override method called interact, which is basically just sitting on our interactable class or C# script. That's cool, and that's super helpful in the future, since we already can use that same functionality for our chests. So they will have any thing which or any script on them which is calculating, for example, the loot is coming out of it, and we can derive it from interactable as well. And according to whatever we are overriding that particular function with, we can act differently. So what we do is we always, no matter where we are clicking and moving, we always just say whatever the target is we have clicked, we get the component of type interactable, so we can call the interact function directly on that. And how we do that and about all that chests we're gonna do in the next part. Thanks for watching the tutorial. I hope you enjoyed it. Don't forget to subscribe to my channel if you haven't already. Thumbs this video up if you like it, and feel free to become my patron or donate by using PayPal to support me and my channel in the future. All links will be below in the description. See you in the next tutorial. Bye bye.